Hello, future archaeologists. We have a really cool project to work on right here. We're going to be creating a Pythagorean theorem calculator. And this is an assignment that is on the website, but this is just a video walkthrough for it. So I'm going to show you how I would do this if you're having any problems with it, or you want to see what I consider to be one of the most efficient ways to do this. So let's start with just creating a function that would allow us to solve for Pythagorean. Now, the very first thing that I'm going to do, and it was a little bit later on the list, but I just wanted to break up the instruction that way, is I am going to, from math, import square root. So that right there allows me to use the square root function. Inside, there is this thing called a module, and the module is named math, and it has these lists of different math commands that you can do. So I'm importing square root because it's not one of the standard functions that come in here. So now from there, I can start creating my function. So I am just going to define this as Pythagorean. And now what my inputs are going to be side A and side B. So with these two inputs, and I'll put a colon right there to say that I'm starting my function, I indent and go over. I can now write out what I am looking for. So in the Pythagorean theorem, our goal is to find side C. So side C is equal to, and this is something that I did not show in the notes. This is a little cool bonus if you watch the video. Pow. Pow allows us to not fight like a superhero, though I wish it was. It allows us to add something to a different power. So right here, when I start my parentheses, we get our base to an exponent, and then you can have a modifier. So you don't really need to have that. But in this situation, I want side A, whatever the length of side A is, to the second. So I'm going to put comma 2. And now that's what I have for my exponent. It's a little faster than writing out side A times side A. And that's only if it's to an exponent of 2. But imagine if you had an exponent to 4, you don't want to write out side A, side A, side A, side A. You're just going to put side A, comma 4. Pow, side A, comma 4. So now we can add that to, we've got pow of side B, comma 2. And we can close that up, and we want to square root this. So we're going to sqr square root. So now we want to return side C, because that's what we want to get out of this function. So now if I go and I call this function, I can call Pythagorean, and I can name these. Let's say we're going to do the example, so 3 and 4, and I want to print this. So I'm going to print Pythagorean 3 and 4. So now if I go and I run module, save it, okay, it gives us our answer of 5. Perfect, it works. That's exactly all that we needed to do. But I want to take this one step further. I want to turn this into a calculator that we can just punch in our numbers and get the other side out. So how I'm going to do that is I am going to ask for inputs. So I'm going to say that side A is equal to input, then parentheses, and this is going to be what length is side A, and then I will give that a little option right there, and then I will enter and do side B equals input what length is side B. Cool. So then I can close that right there. And now I've got a closer to a calculator. because it's going to ask what those are. Because I'm already asking for side A and side B, I don't need to specify them. So I can actually take out those. I can take out this. And then when I run this function and I say, okay, what is the length of side A? 3. Length of side B? 4. Oh, let's see. What did I do? So we've got an error. Side C. We've got power. 2. I think I still need to throw in side underscore A and side underscore B over here. I got that by reading oh, I think it's the integer type. Yeah. Ah, I see what it is now. Now it's saying that it is unsupported. We've got string and integers. So we need to make sure that when we have inputs, we're importing those as strings. We need to remember that. That's my little goof. So we're going to call that an integer as our inputs. So now let's try running. Run module, save, okay. So we've got 3 and then 4. Nope. 2 arguments given. It might be this right here because we don't need this anymore. Run module. Okay. Side A, 3, 4, 5. There we go. Now it works. So if we wanted to change this up a little bit more, we could even add a print side C is equal to ... parentheses. And now we've got a Pythagorean theorem calculator. So I can run this function, say, okay, what is length of side A? We'll say 5. 9. Side C is equal to 10.3. 10.3. So there we go. We have a calculator that works for Pythagorean theorem. We're able to use a little bit of the debugging too to figure out what was wrong with it. So I hope that you enjoyed that, and I'll see you in the next one. Bye.